So right now we are going to conduct a basic static analysis on this malware. As mentioned before, there's a new folder called source0.4.zip. And after extracting it, there's a few more folders called edit server and server. And there's one more zip folder called dsm.zip. Extracting it out will actually reveal another folder called dataspy.emp. But once you see inside here, it's all basically some sort of images, I guess. Like it's all basically about uh GUI based images. Yeah, it looks some kind of like a GUI based images, and there's also text over here which says nothing much actually. Moving on to this server, there's a lot more files over here. There's a lot of header files, .h files, and .cpp file. And under release, there's actually one folder called editserver.exe. Once you click on it, there's actually like this, and you actually see that you'll be surprised that there's actually it's a customizable malware. So as you can see here, there's an IRC server. So IRC is internet relay chat, whereby it's a more secure communication between two parties using just IRC server using a port number. And also there's also channel key and password for authentication purposes. Also, you can see that it's a created with like port 8000 or something, just random port number. And as you can see, there's actually something called pack after create, which means that it most likely means the malware is going to be packed after the creation. We'll just find out over here. So there's also reply to like channel query and notice, which will just set it notice as a case. So just create one here now. So as you can see here, there's something called dsnx.exe, which will just rename it to dsnx. However, what we'll find out right now is whether or not these two files are the same as the one which we got. So just use winmd5, drag in the newly created one. So you can see the hash value, which is this, and then this one, which is this. As you can see here, both of them have different hash values and therefore proving that both are not the same. And the newly created one has a smaller space than the original. So further on with this, we'll use PID to check whether it's a packed or not. Especially since just now we saw that it was a packed malware, we can just further confirm our suspicions now. So the drag and drop here, you can see it's actually created by UPX. This malware is not the one which we use as on, but a newly created one. So we'll just use the unpacker for UPX and unpacking done. And then we'll use the unpack malware now to actually put inside the hash value. And you can see here it's all different. Even the pack and the unpack are different, and the size has significantly increased. Furthermore, there is also another case. Furthermore, we'll just create another package, I guess, 7000, but without packing the malware. So when we create the exe, okay, so let's create the exe. So let's do this right now. Okay, so we just shift it to here right now. Oops. Okay, I guess because yeah. So just create a new one right now without unpacked. And as you can see, it's a new one which we now plug it to here, and there's a different hash sum. Using a PID again, we then say that this is unpacked, so proving that packing is also optional. But the malware which we got is actually unpacked, which we have over here is unpacked. While we are not sure, while it's actually true that there's actually a customizable malware, it's also showing that this type of malware can be made with different situations in mind, and the fact that it does not have the same malware that is created. So as you can see here, this is actually Microsoft Visual C++, so meaning that it's not packed malware, so it's easy to do analysis directly. No unpacking is required. So further on, we will actually use PE view, then we drag and drop it, and then we'll see more information as in when the program was created, and signature in which file here. So as you can see here, it was created on the 3rd of June 2001 at 2:22, but it's very long ago, which is very long ago. So now we know about that. Now we'll just use dependency, just use bin text to see what's actually inside. So in this whole bombarded form of strings, we actually find quite a lot. We can find some useful information, such as register, close key, delete, open, and set value. So this shows that this program actually modifies registry values. Get local time shows the fact that the malware is asking for a time, and you can see here user ID equal Unix, so it can't be like a login kind of thing. And also this part shows that it's actually a persistent malware that is staying in the run folder. And there's also one more thing called WinDSNX. This can be a mutex, which will be seen in the following sections. Also, going down more, it's very hard to find. So there's a write file, create file A, and get file size, which is basically file manipulations, read file also. And also create thread means that you can't create a thread. And also there are more things such as set keyboard state and get keyboard state, most likely meaning it's like a keylogger. Yeah, and also as mentioned just now, registry value, registry modifications, and also get system time, get startup time, and everything. So meaning that it's actually getting information from the computer itself. So yeah, just about it. More information will be added in the report. Will be in the report. So last but not least, we'll just use dependency walker. Same thing, drag and drop. So you'll find that there are actually 6 DLLs, RAS API 32. RAS stands for Remote Access Services. So this actually you can see there's a RAS enumeration connection and get connection status. So it's meaning it might be a Trojan that's communicated via backdoor. Kernel 32.dll, there are quite a lot of import functions, but the main thing that is we focus on is copy file, which was seen in the bin text as well. So there's also like file modifications and other important DLLs. Yeah, then after that there's user32.dll, which also contains like get keyboard state, as mentioned just now, and WS print, so it's trying to print something out. ADB API consists of the registry modifications, and shell32 consists shell to execute a, which just execute a shell, and winsock32, though there's nothing over here. Inside WS32.dll you can see that, which is actually winsocket32, which is a smaller one. It consists of all these socket names and other stuff. Yeah, that's about it. That's about it for static analysis, basic static analysis.